Let's do some math. So today we're going to be learning about angles of elevation and angles of depression. Pretty much, this is trigonometry, but word problems. You're going to have to draw your own picture first, and in that picture there'll be some sort of right triangle, and then you'll have to solve using trigonometry. Angles of elevation and depression, if you look at the first line, are always formed with a horizontal line. So check out what I'm highlighting there in green. Okay, you have to be next to the horizontal line. If you are not next to the horizontal line when you're choosing your angle, you are about to do the problem wrong. So let's check out what that looks like. If you're looking at an angle of elevation, okay, it's like you're looking up at an airplane. The angle is formed by this horizontal line, I'm highlighting it in red, the horizontal line, and the angle you actually look up. That is your angle of elevation. It starts horizontal and then it looks up. Okay, that's your angle of elevation. You elevate, go up, your head goes up, it elevates. Now suppose you're standing on a cliff, or you're standing somewhere, wherever, and you got this horizontal line, that's your eyesight, if you look straight ahead, horizontal line, but you decide you're going to look down. You depress your head, okay, that means go down. That angle there, starting from the horizontal line going downward, however many degrees you went down, that's your angle of depression, the measure of your angle of depression, okay? You have to go, again, you have to go from this horizontal line. If you don't go from the horizontal line, you're picking the wrong angle and your whole problem is going to be set up poorly. All right, let's take a look at this example. So example 1 says, suppose you're a lifeguard looking down at a swimmer in a swimming pool. Your line of sight forms a 55-degree angle with the horizontal line. You are 10 feet up in your seat. How far is the swimmer from the base of the lifeguard stand? Now, here's the second thing you got to really be careful of. You have to draw a good picture. Not only does your angle have to start from the horizontal line, but you have to have the right picture to be able to do that. And here's what some people do. So, they draw the water. And then let's see, they draw a swimmer in here. So here's somebody oh, why didn't that? Let's see, they draw somebody in here swimming. Okay. And then a lifeguard. I think they wear red sometimes, right? So here's a lifeguard. And maybe there's a big umbrella over the lifeguard as well. That way they don't get too much sun on them during the day. Okay. And what people end up doing, by the way, I'm drawing in front of you, even though my drawings aren't very good. I'm doing this to show you that you don't have to have a good drawing. What some people do is they draw this line first, and that's great. But the thing is, you could draw this triangle, or technically, I'm going to do this in a different color, green, you could draw this triangle. And notice, both of these are right triangles now. Okay, and you might say, oh, Mr. Fife, that's a good point. Okay, which one's the correct triangle to draw? Where's my horizontal line? And I'm going to tell you, it doesn't actually matter. Watch this. This 55-degree angle is touching a horizontal line. So is this 55-degree angle. It touches a horizontal line. And in fact, because of the angle-angle relationship here, 55 degrees and then the right angle, 55 degrees and the right angle, these two triangles are the exact same. They are both, well, they're similar. And then because we know these distances are the same, the distance from the lifeguard to the swimmer horizontally, we have angle, side, angle, and we know that those two triangles are congruent. They're the same triangle. So no matter what, we're going to find the same thing. We know this is 10 feet up in the ground, whether we're using the green triangle, or this is still 10 feet if up and down vertically if we use the triangle that I drew in black here. Either way, we have the same triangle. You can use the same angle. You just have to solve it using that angle that touches the horizontal line. Here's what you cannot do, is you can't draw the triangle in black and then choose this as the angle. This angle right here, which I put a big T on for this, okay, this angle right here in blue, that angle is the one you can't use, okay? That does not touch a horizontal line. So let me get rid of that angle in blue. As long as you use either of these angles in the in black there and 55 degrees, you're good to go. Now, second thing I've noticed that I did myself here that I don't suggest you do is I drew it really tiny. I should have used more of the space, okay? Don't be scared to do that. All right, now it says, how far is the swimmer from the base of the lifeguard stand? And notice it says base of the lifeguard stand. It's not saying go straight from the swimmer to the lifeguard. It's saying down here in red, how far is that distance? Okay, so let me redraw one of the triangles. We were 10 feet up in the air. We want to know this distance, and this 55-degree angle touches a horizontal line. Okay, so now we can use trigonometry to solve this thing. So I'm going to label my hypotenuse and my adjacent, and then I'll label the opposite over here. That's opposite the 55 degrees. And it looks like the adjacent and the opposite both have an x and a 10 on it. Okay, the adjacent and the opposite are the two I'm going to use. And so is that SOHCAHTOA? Which one is that? It looks like it's tangent. Okay, I'm going to say tangent of the angle equals opposite 10 over adjacent x. Remember, if you're solving these things, I like to solve these things by making both sides fractions. 10 times 1 is 10. When you cross multiply here, since you have a proportion, you can cross multiply. X times tangent of 55. Tangent of 55 is a number, so I put it in parentheses to remind myself of that. I can divide by that number. I could plug it into my calculator if I wanted to. When I divide by it, I get x by itself on the right side. But if I do it to the right side, I also need to divide by tangent of 55 on the left side. Then I go to my handy dandy graphing or Desmos calculator, the scientific calculator, and I say, well, hey, what's 10 divided by tangent? I need to go to the function, tangent of 55. Looks like it's 7.00, so I'll just say about 7. I'll use this little about instead of equal to, about 7. So the lifeguard and the swimmer are 7 feet away. Okay. Let's take a look at another example. This example says a 100-foot tall building is casting an 80-foot shadow. What is the angle of elevation of the sun at that moment? Round to the nearest tenth of a degree. So we have a giant building casting a really long shadow on the ground. Okay. The sun comes in. The sun is, I don't know, red and orange and yellow, but I don't think I have all those colors. I have red. So here's the sun. It casts a shadow. Okay, just like that. Casts a shadow. The 100-foot tall building casts an 80-foot shadow, and we want to know the angle of elevation, of the sun. So I have a question for you. Would it be this angle here or this angle here? I want you to answer that in your head, and I'll tell you the correct answer in a second. It would be this angle right here. Why? Literally, why? I'm not asking. Okay, it's that one. It is not this angle that I labeled as X because that angle doesn't touch a horizontal line. Angle Y does. Okay, so now we have our triangle. Sometimes I redraw all these triangles. This one literally looks like a right triangle, so I don't think I'm going to redraw it much. Let's see. I drew my picture. Boom. I labeled what I know and what I'm trying to find. Now I need to find the angle of elevation. So to do that, I need to, from my angle, start labeling things. My hypotenuse is here. My adjacent is here. So they both make up my angle. That's why I know adjacent is the other one. And opposite is farthest away from the y value. Okay, it's across from that y angle. So it looks like I'm going to use opposite and adjacent again. Remember, SOHCAHTOA. So that's tangent again. Tangent of, well, I don't know the angle, so I'll say tangent of my angle, y, is opposite 100 over 80, adjacent. How do you solve an equation if you're solving for the angle? We learned this, I think, last class. But how do you get rid of a tangent? We want the y to stay. We want to get rid of the tangent. Well, the opposite of a tangent is inverse tangent. Those cancel. I'm left with y. I need an inverse tangent the other side of my equation. And so when I do that, I'm going to go to my handy-dandy Desmos scientific calculator. I'll push function, inverse tangent. Go back to the main part here. I'll even push fraction, 100. Go to the bottom of the fraction, over 80. Enter. 51.34. So this angle here, y, is 51.34 degrees. Cool. Let's check out one more example. We're going to draw a picture and solve for one more example. All right, suppose you look up at the top of the building. The angle of elevation from your eyes to the top of the building is 65 degrees. I'm going to pause here and I'm going to draw my building. Okay, you look up to the top. So you're down here. Okay. Suppose you look up at the top of the building. The angle of elevation from your eyes to the top of the building, 65 degrees. Okay, here is my triangle. That means this one is 65 degrees. How did I pick that angle? It's touching this horizontal line right here. Okay, this angle is made up by the horizontal line. That's why I picked it to be 65. I'm standing 80 feet from the building. That means this is 80 feet. I'm 80 feet away from it. And your eyes are 5 feet above the ground. Wait a second, why does it tell me that? Okay, this whole height of the building's not 5, but my eyes are 5 feet above the ground. How tall is the building? What we're going to have to do is find this part x of our triangle, and we're going to have to add 5 more, because that's where our eyes start, to get the entire length of the building. So what we're doing is actually finding this question mark. We have to find x, because it's part of the triangle first, and add 5 feet. Our eyes start 5 feet above the ground. So let's see. I'm going to redraw this one, because there's kind of a lot going on. 80 feet away, 65 degree angle of elevation. I'm solving for x. I'm going to go ahead and label these first. Always label. I've got hypotenuse, adjacent, and opposite. Oh my goodness, it's another tangent. So, ka, toa. Okay, I've got opposite and adjacent. I don't use hypotenuse, so it's another tangent. So tangent of 65 degrees equals opposite over adjacent. When I cross multiply, I make both sides. Let me go back. I'll change colors first. When I make both sides a fraction and cross multiply, I get x, the height, or the x value of that triangle, is 80 times tangent of 65. I like to put parentheses around tangent of 65 to remind myself that it is a number. I pull up this calculator and I go to function. I hit tangent. Go back to the main of 65. And then I need to end my parenthesis right there and multiply that by that value by, what was it, 80? Yeah, 80. And I get 171. So x is about 171. There might have been some decimals there. Ooh, it does say to the nearest tenth. So 171.6 when I round it. Okay. Now, that means this is 171.6. Oops, 6. But is that my answer? No, the height of the building then is 171. The building height is 171.6 plus 5 more, because that's up to my eyes, was 5 feet. So I get 176.6 feet. Pretty tall building. All right, so as you're thinking back about angle of elevation and depression, make sure you always choose the angle that is next to the horizontal line. Please draw your pictures carefully. Think about which things are horizontal, which are vertical. The ground would be always horizontal. Buildings or you stand pretty vertically. Once you've drawn your picture, then you got to set up your SOHCAHTOA. So label each side set up your equation and solve. Hopefully that makes some sense. Good luck trying some problems. If you need some help, I'll be around. Just ask. Good luck.